All right, today we're going to talk about combining like terms. We have already started that by looking at the associative, commutative, and distributive property. Today, actually simplifying expressions. Today we're going to add combining like terms to that repertoire. So let's start taking a look at those examples. There we go. All right, so the terms, and you should be writing down these vocabulary words because these will be words that come up over and over again. So please make sure these words are in your notes. The terms of an expression are the parts to be added or subtracted. So for example, and what happened to my pen? Whoops. Sorry about this, guys. I really am trying. Okay. So the terms of an expression are the parts to be added or subtracted. So we saw lots of expressions over the last few days, something like 3x plus 2. Each of these are terms. The 3x is a term, 2 is a term because these are the parts of the expression to be added or subtracted. Then we have like terms. Those are terms that contain the same variables raised to the same powers. So I have an example like 2x plus 6x. I've got two terms that have the same variable and they are raised to the same powers. By that I mean 2x squared plus 6x are not like terms because notice this squared is not the same as x, which is really just raised to the 1 power. Okay, does this make sense? Hopefully. Also, constants can be like terms. So if I had 2 plus 6, those are also like terms because those are both constants. Coefficient. A coefficient is a number multiplied by a variable. Okay, so coefficients, like terms, can have different coefficients. Look up above. We had 2x plus 6x. The coefficients, that's the number multiplied by the variable 2 times x, those can be different. Okay? But obviously we can combine these. If I have 2 x's or 2 apples plus 6 x's or 6 apples, I've got 8 apples altogether. However, if I have 2 x's and 6 y's, that's like having apples and oranges. They're not going to combine. I still have 2 x's and 6 y's, but I'm not going to be able to do anything with those. I can't add them together. What if I have 3x and x? That x doesn't have a coefficient, except that x does have a coefficient. We just don't see it. It's the number 1. So if a variable has no coefficient, you know that's really a 1. Okay? Likewise, x squared is really 1x squared. And remember when we saw this goes back to our distributive property, just to make sure everybody got that worksheet correct. Remember we saw a problem where it had a negative sign in front of, I don't remember what it was, maybe 3b minus 2. That's if there's no coefficient in front of that term, this is considered a term because it's in parentheses, I can assume that's a 1, so that really was negative 1 times 3b minus 2. Okay, so hopefully when you did the distributive property on that worksheet, you came up with negative 3b plus 2. Okay? So, combining like terms, we're going to go ahead and add these together. So now this makes sense, hopefully. We've got y's and we've got more y's. So, in fact, these can be added together. These are like adding two sets of oranges together. I've got 8 y's and 42 y's. So in total, I've got 50 y's. Here I've got 4w squared minus another w squared. Remember, there's no coefficient there, so I have to assume that's a 1. I do have the variables raised to the same power, so I can combine these. So I've got 4 w squareds, and I'm subtracting 1 w squared from that for 3 w squared. And finally, a 5x squared plus 5x. it was kind of cool that the coefficients were the same, but my variables are not raised to the same power. So I actually can do nothing to combine these like terms. All right, your turn. You've got 3 expressions here. I would like you to combine these like terms. Go ahead and pause the slide, get these done, and come back and check out the answers. Let me get those answers down for you so you can check. 72p minus 25p, sorry, 147p. I'm adding these two. I get 7/4 x to the 4th. And finally, I've got an m here and an n here, so I'm not going to combine those, so I am done. All right, so I'm going to take you through the process of simplifying an expression using all of the different properties we had before. I am going to list out the properties for you here. I just need you to know what the commutative property and associative property are. I will ask you many times to name the distributive property, but I mostly want to see that you know how to do it. I don't actually care that much that you'll be able to name it. You will later on probably be asked a question randomly, is this associative or commutative, but I'm sure you know the difference. So I'm starting with 3 times the quantity x minus 2 plus 10x. Now remember, I've got the order of operations, so I need to do things in a specific order. So first I'm going to use the distributive property, right? I've got to multiply the 3 times the x, then the 3 times the -2, because remember subtraction is the same as adding the opposite. Then I'm going to multiply through, so now I have 3x minus 6, and I still have the plus 10x over there. I'm just moving this 10x over to here so that I can combine these like terms, so I'm using the commutative property. Remember, it tells me I can commute or move those terms. Oops. And then finally I'm going to use the associative property to combine these two terms to get 13x, and then I still have my minus 6. So I've combined the like terms and I have still 2 terms, but since this one has a variable and this one's a constant, I am done. Okay, so another time you have the opportunity to try this. I don't need you to write out what properties you're using, but I will ask you to write down all the steps. So you can pause the video and try this out yourself. Combine these two, and finally that is my answer, 18x plus 8. Okay, a challenge one for you. So you're going to simplify the following. It's the quantity 2b plus 5 minus the quantity, remember to put in your parentheses, 8b plus 6 plus 3 times b minus 2. I'm going to ask you in your quiz to write down this expression, and then for bonus points I'm going to ask you to solve it. And that's it for our video today.